What happens when a star the size of Jupiter goes rebel? Betelgeuse, quite possibly one of the most splendid stars in our night sky, is encountering a puzzling change that has cosmologists baffled and excited. Imagine a star so massive that it would predominate our Sun and immerse all the planets up to Jupiter if placed at the center of our solar system. This behemoth is Betelgeuse, a red supergiant star situated in the constellation Orion. For centuries, Betelgeuse has been a celestial marvel, enrapturing stargazers with its striking rosy tint and enormous size. However, recently, this grandiose giant is acting unusually, and space experts are on the edge of their seats. In a stunning turn, Betelgeuse has recently experienced a sudden increase in brightness, flooding by more than half and jumping from the 10th to the 7th most brilliant star in the night sky. This dramatic change has left researchers astounded and eager to unravel the mystery behind Betelgeuse's transformation. What could be causing this unusual behavior? Is Betelgeuse nearing a catastrophic event, or is this simply a temporary stage in the star's life cycle? To understand the significance of Betelgeuse's strange conduct, we need to delve into the factors that contribute to a star's brilliance. A star's brightness is determined by its size, temperature, and distance from Earth. Betelgeuse is a true giant among stars, with a radius more than 1,000 times that of our Sun. Despite its immense size, Betelgeuse is relatively cool for a star, with surface temperatures ranging between 3,000 and 3,500 Kelvin, giving it its distinctive red hue. For as long as history, ancient civilizations have been captivated by Betelgeuse and have woven the star into their legends and myths. The ancient Egyptians associated Betelgeuse with the god Osiris, the ruler of the underworld, while the Greeks linked the star to the mythical hunter Orion. These stories serve as a testament to the enduring allure of this celestial wonder. As cosmologists continue to monitor Betelgeuse's puzzling behavior, they are left with burning questions about the star's future. A lot is at stake, and the outcomes could be downright galactic. If Betelgeuse is indeed nearing a supernova explosion, it would be an extraordinary event that could light up the night sky like never before. The explosion would be so bright that it would be visible even during the day, casting shadows on Earth and providing a remarkable opportunity for scientific study. But the question remains, is this the calm before the cosmic storm, or simply a temporary anomaly in the life of a stellar giant? Understanding the star's immense size and its current stage in the cosmic life cycle is key. Betelgeuse is a red supergiant, a type of star nearing the end of its life. Stars, like living beings, are born, grow, and ultimately die. They begin their lives in enormous clouds of gas and dust, where gravity organizes material to form protostars. As these protostars gain mass and temperature, nuclear fusion ignites in their cores, marking the birth of a new star. Over millions or billions of years, stars like Betelgeuse burn through their nuclear fuel, fusing hydrogen into helium and then helium into heavier elements. As they age, the internal dynamics of these stars change, leading to a series of transformations. When a star with a mass like Betelgeuse's depletes its fuel, it expands to a colossal size, becoming a red supergiant. At this stage, the star's outer layers are barely held together by gravity, making it extremely unstable. The fate of a red supergiant like Betelgeuse is to eventually collapse under its own immense weight and explode in a catastrophic event known as a supernova. Supernovae are among the most powerful and radiant events in the universe, releasing an enormous amount of energy in a brief period. Betelgeuse is destined for a Type II supernova, which occurs when a massive star runs out of nuclear fuel and can no longer support its own mass. The core of the star collapses, triggering a shockwave that destroys the star, flinging its outer layers into space at unimaginable speeds. If Betelgeuse were to go supernova, it would be a sight like no other. The first sign of the impending explosion would be a massive surge of neutrinos, elusive subatomic particles that rarely interact with matter. These neutrinos would escape from the star's core moments before the shockwave reaches the surface. Observatories around the world would be instrumental in detecting this neutrino burst, alerting astronomers to the impending supernova. As the shockwave reaches Betelgeuse's surface and the star detonates, an immense amount of energy would be released as light, heat, and other radiation. the supernova would quickly brighten, becoming visible to the naked eye on Earth, even during the day. At its peak, the exploding star could outshine the full moon, casting shadows and turning night into day for weeks. The excitement surrounding Betelgeuse's potential supernova is palpable among astronomers. As Dr. Emily Thompson from the University of California, Berkeley, puts it, Betelgeuse is a ticking time bomb, and we have the honor of witnessing its final moments. A supernova of this magnitude would be a once-in-a-lifetime event, providing a unique opportunity to study the death of a massive star in real time. It would be a scientific gold mine, offering insights into stellar evolution, atomic physics, and the cosmos itself. Substance enhancement of the universe. Anyway, the narrative of Betelgeuse took a surprising turn in late 2019 when the stars abruptly started to diminish rather than proceeding with its sensational lighting up. This diminishing was influential for such an extent that it was perceptible even to the unaided eye, with Betelgeuse blurring to around 40% of its common splendor. The cosmic community was confused by this abrupt change and mixed to notice the star all the more intently, wanting to unravel the reason behind its blurring light. The darkening of Betelgeuse represents an entrancing test for space experts. Is this an indication of an approaching cosmic explosion, or is there another clarification for the star's uncommon conduct? The secret develops as we consider the potential outcomes, and the expectation grows as we anticipate further observations and data. However, the narrative of Betelgeuse is far from being done. The destiny of this confounding star holds the key to understanding the very nature of the universe and our place within it. Betelgeuse continues to enrapture cosmologists as its surprising way of behaving sparks a whirlwind of new hypotheses and observations. With the red supergiant star declining to follow the content, researchers are attempting to beat the clock to address the riddle before the astronomical show reaches its peak. In late 2019, cosmologists were staggered when BGW, quite possibly one of the most brilliant stars in the night sky, unexpectedly began to faint. The star, which had been a constant presence for years, was now blurring right in front of them. Hypotheses ranged from dust clouding our view to the star experiencing a huge surface commotion. However, the reality remained elusive as the darkening situation developed. Space experts trained their telescopes on Betelgeuse, eager to capture any pieces of information that might assist them in unraveling the mystery. The extremely large telescope ELT, in Chile, one of the most advanced observatories on the planet, managed to capture a series of images that would prove essential in understanding the star's behavior. The ELT images revealed that Betelgeuse's appearance was far from symmetric. The star, which had once appeared as a uniform circle, now had a distinctly unbalanced shape. It was as though an infinite hand had reached out and crushed the star, leaving it deformed and mutilated. But the deviation was only the beginning. As space experts broke down the data, they found the presence of a colossal shock in our view. This shock, which was unlike anything they had seen before, appeared to be emanating from the star's surface, suggesting that something truly extraordinary was occurring on Betelgeuse. To comprehend the significance of these discoveries, we need to explore the concept of a photosphere. A star's photosphere is essentially its visible surface, the layer from which light is emitted into space. In the case of Betelgeuse, astronomers had long expected the star's photosphere to be relatively steady, with only minor variances over time. However, the ELT images told a different story. They revealed that Betelgeuse's photosphere had begun to grow, making the star appear larger than ever before. Perhaps the star was slowly puffing up like a cosmic balloon being inflated by a hidden power course. As astronomers raced to understand these observations, they found two more anomalies that would shed light on the star's behavior. In mid-November 2019, just as Betelgeuse was reaching the peak of its dimming event, they observed the appearance of a dark southern hemisphere on the star's surface. This region, which had previously been as bright as the rest of the star, was now significantly darker, suggesting that something had caused a major change in the star's appearance. At the same time, cosmologists detected a significant drop in Betelgeuse's surface temperature. The star, which typically burns at around 3,500 degrees Celsius (6,332 degrees Fahrenheit), had cooled by several hundred degrees in just a few months. This rapid temperature change is extremely surprising for a star like Betelgeuse, and it suggests that some sort of unexpected dramatic event had occurred on the star's surface. To understand why this temperature decrease is so peculiar, we need to consider the nature of red supergiant stars like Betelgeuse. These massive stars are in the final stages of their lives, having exhausted the hydrogen fuel in their cores and begun to fuse heavier elements. As a result, they have expanded to enormous sizes, with radii that can be hundreds or even thousands of times larger than our Sun. Despite their massive size, red supergiants are actually cooler than smaller, younger stars like our Sun. This is because their expanded atmospheres allow more of their energy to escape into space, resulting in lower surface temperatures. However, these temperature changes typically occur slowly over time, on the scale of years or even centuries. The fact that Betelgeuse's temperature decreased so quickly and by such a significant amount is therefore highly unusual. It suggests that a major disruption took place on the star's surface, one that disturbed its usual temperature regulation mechanisms. As the evidence mounted, astronomers began to converge on a stunning conclusion: Betelgeuse had likely experienced a huge surface mass ejection, SMEs are powerful ejections that occur when a star expels a large portion of its mass into space. While SMEs had been theorized for years, no one had ever directly observed one on a star like Betelgeuse. The implications of this discovery were staggering. If Betelgeuse had indeed experienced an SME, it meant that the star was considerably more unsound than recently suspected raised inquiries regarding the star's future and whether it very well may be moving toward the end of its life. Yet, the SME, supermassive surface mass ejection, also presented a fantastic opportunity for space experts. By concentrating on this phenomenal event in real time, they could gain new insights into the internal workings of huge stars and the processes that govern their development. It was an opportunity to observe the grand show of heavenly death and resurrection, to see firsthand how the universe reuses itself on a grand scale. Imagine if Betelgeuse's diminishing is simply the beginning of a much larger mystery. The gigantic surface mass ejection, SM, that Betelgeuse experienced can be compared to a star-sized volcanic eruption of stunning magnitude. Imagine a heavenly giant, a star so massive that it midgets our Sun, suddenly expelling a huge amount of material from its surface. This enormous ejection sends shockwaves undulating through the surrounding space, creating a huge crest of gas, atoms, and dust that partially darkens our view of the star. The scale of Betelgeuse's SME is truly awe-inspiring. Stargazers estimate the star launched out a staggering 400 times more mass than a common event on other stars. To put that into perspective, the amount of material lost by Betelgeuse is equivalent to several times the mass of Earth's moon. If you were to gather all the ejected mass and shape it into a mountain, it would make Mount Everest seem like a mere stone in contrast. To further illustrate the incredible scale of this event, consider this: if you took all the water in Earth's seas and converted it into gas, it would still be a small fraction compared to the volume of material that Betelgeuse expelled into space. The SME was an infinite display of incomprehensible extents, a demonstration of the raw power and grandeur of the universe. Yet, the SME wasn't simply a visual spectacle, it also had a significant influence on Betelgeuse itself. The star lost so much mass during the event that it altered its throbbing period. Before the SME, Betelgeuse's surface extended and contracted on a regular 400-day cycle. After the launch, that period was halved to only 200 days. Changes in a star's throbbing period can have expansive ramifications for its stability and longevity. Throbs are like the heartbeat of a star, and when that rhythm is disturbed, it can be a sign that the star is entering a new phase of its life. For Betelgeuse, the altered throbbing period suggests that the star may be one step closer to its inevitable fate, a colossal supernova explosion. To better understand the cause of Betelgeuse's SME, astronomers turned to cutting-edge scientific simulations using complex calculations and powerful supercomputers. Scientists created detailed models of the star's interior, mimicking the intricate physical processes that govern its behavior. These simulations revealed that a curiously hot current of gas, like a massive boiling bubble, rose from deep within Betelgeuse and burst through its surface, triggering the ejection of material. The simulations used by astronomers are marvels of modern science. They integrate a wide range of factors and variables, from the star's temperature and density to its magnetic field and rotation rate. By feeding in data from advanced telescopes like the Extremely Large Telescope (ELT) and the Hubble Space Telescope, researchers can create a virtual replica of Betelgeuse, a digital twin, that allows them to study the star in unprecedented detail. With these simulations, cosmologists can explore the potential causes and consequences of Betelgeuse's SMME and pulsation changes. They can model the star's evolution over millions of years, watching as it grows and changes, ultimately meeting its fate in a burst of tremendous brilliance. These simulations offer a window into the core of the star, providing a glimpse at the complex and often surprising processes that shape the universe around us. With the clock ticking down to Betelgeuse's inevitable supernova, what cutting-edge technologies and innovative methods are astronomers using to unlock the star's mysteries before it's too late? One of the most pressing questions on astronomers' minds is when Betelgeuse could finally go supernova. Based on the star's characteristics, estimates range from a mere 10,000 years to as much as 100,000 years. However, predicting the exact timing of a supernova is no simple feat, as numerous factors influence a star's lifespan. A star's initial mass, structure, and rate of nuclear fusion all play significant roles in determining how long it will live. Betelgeuse, being a red supergiant, has already exhausted its hydrogen fuel and is now fusing heavier elements in its core. This process is less efficient and can lead to instability, bringing the star closer to its cataclysmic demise. Yet, even if Betelgeuse were to go supernova today, we wouldn't know about it immediately. The star is located about 650 light-years away from Earth, which means that any light or signal from the supernova would take 650 years to reach us. Essentially, when we observe Betelgeuse, we see it as it appeared many centuries ago, not in real time. This concept of light years is crucial to understanding the distances involved in cosmic observations. A light year is the distance light travels in a single Earth year, roughly 9.46 trillion kilometers or 5.88 trillion miles. To put that into perspective, if you could travel at the speed of light, it would still take you 650 years to reach Betelgeuse. Despite the uncertainty surrounding Betelgeuse's ultimate fate, its current state offers astronomers a unique opportunity to study the surface of a star up close. By observing the star's dimming and its massive surface mass ejection, researchers can learn about the behavior of aging stars and the processes that lead up to a supernova. This knowledge has broad implications for various areas of cosmology. Understanding stellar surfaces can help us better interpret the data we gather from distant stars and exoplanets, providing insights into their compositions, atmospheres, and potential habitability. Furthermore, studying the life cycles of stars like Betelgeuse contributes to our understanding of cosmic evolution and the distribution of heavy elements throughout the universe. As we consider the fate of Betelgeuse, space experts have also made another exciting discovery: the first ever observation of a star consuming its own planet, found 12,000 light-years away in the constellation Water. This astronomical phenomenon was detected using cutting-edge instruments and innovative analysis techniques. By measuring the subtle changes in the star's light as the planet was consumed, astronomers were able to simulate the event and gain unique insights into the dynamics of star-planet interactions. This groundbreaking discovery opens new avenues for studying the formation and evolution of planetary systems and may even shed light on our own solar system's ultimate fate. In the ongoing exploration of Betelgeuse and other celestial phenomena, we see a testament to the ingenuity and perseverance of the cosmic community. As we continue to develop advanced technologies and creative methodologies, we edge closer to unlocking the universe's secrets and answering some of the most profound questions about our place in it. Thank you for watching. Until next time, don't forget to like and subscribe.